Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. I've been teaching chemistry for 25 years, and I think I've figured out a way to help students learn chemistry in the easiest way possible. Okay. In today's video, we're going to do an extra problem from our limiting reactant and percent yield series. Okay. The last video showed you how to do everything. This video is all about just doing a practice problem. So in this problem, we got pentane reacting with oxygen to make carbon dioxide and water, okay? And if I were to show the prompt to you, it would look something like this. You might want to take a quick screenshot of it. But it basically says, hey, if you have 5 grams of pentane reacting with 10 grams of oxygen, and I performed this experiment and I got 3.254 grams of water, what would the percent yield be? So I like to set up all of my givens in boxes, okay, and then use an underscore to talk about kind of like what the question is asking, okay? So if I'm trying to get percent yield and I have experimental yield, what I'm going to need to figure out is the theoretical yield, because what percent yield is, it's just the division of the experimental yield in the theoretical yield times 100. So I got to get to this point, okay? And the way I'm going to do that is by converting both of these over, okay, into the compound of water, and whatever one's the lower of the two, that one is going to be my theoretical yield. So let's get right into it. I'm going to start out by converting the pentane into water. I have 5 grams of pentane, C5H12, and I'm going to go from grams to moles, moles to moles, moles to grams. So grams of pentane to moles of pentane, moles of pentane to moles of water, and then moles of water into grams of water, okay? The molar mass of pentane is going to be 72 grams per mole. The mole ratio between water and pentane, water is a 6, pentane's a 1, so that's going to be a 6-to-1 ratio, and the molar mass of the water is going to be 18 grams per mole. When I do all of this work, when I convert the pentane over into the water, okay, I end up getting a value that's equal to 7.50 grams of water. Now, I don't know if that's my theoretical yield. I got to do the same thing with the other reactant. So I'm going to convert the 10 grams of oxygen into water as well. So I'm going to go from grams of oxygen to moles of oxygen, moles of oxygen to moles of water, and then moles of water to grams of water. Molar mass for oxygen is going to be 32 grams per mole. The mole ratio between the oxygen and water is going to be 8-to-6. 8 for the oxygen, 6 for the water, and the molar mass of the water is still 18 grams per mole. And when I do all this work, I get 4.22 grams of water, okay? So I moved both of the reactants, and I converted them to a common product. And I do that so I can evaluate them, okay? Whichever is going to be the lower of the two, 7.5 versus 4.22, 4.22 is the lower of the two. This is what's going to be called my theoretical yield. And I'm going to use this number, 4.22, to calculate my percent yield. Remember, percent yield is equal to the experimental yield over the theoretical yield times 100. So my experimental yield is 3.254 grams of water. And that's how much I actually made in the experiment. So this either has to be done in the experiment or it has to be given to you in a prompt, as it was in this particular problem. But I should have made 4.22 grams of water based on the starting ingredients that I have. Okay, of course, times 100 will give me a percent yield of 77.1%. Okay, so that's the answer to the question. But I'd like to go a little bit further with you guys, okay? Because this deals with limiting reactant, I'd like to throw out a couple other vocabulary words, okay? Now that we've converted both of these over, whichever is the lower of the two, if you work backwards, which would be the oxygen, okay? It's the oxygen that we call the limiting reactant. So when this chemical reaction is done, okay, there is no more oxygen left over whatsoever, okay? All of this oxygen, all 10 grams of oxygen have been reacted to form the 4.22 grams of water, okay? That also means that the pentane is the reactant in excess, okay? Which means that some of the pentane reacted, not all of it, which means that there's some pentane that did not react. And what I want to figure out is, well, how much of this pentane is left over after this chemical reaction is done? So what you like to do is you like to convert your limiting reactant, because it controls everything in the chemical experiment. I'm going to convert that over, the limiting reactant, over into the reactant in excess. So I'm going to start with my 10 grams of oxygen that I know completely reacts, and I'm going to convert it over to the pentane to figure out how much of the pentane reacted. So let's go ahead and set that up. So grams of oxygen to moles of oxygen. Moles of oxygen to moles of pentane, C5H12. And then moles of the C5H12 to grams of C5H12. Molar mass of oxygen is 32.0 grams per mole. The ratio between the oxygen and the pentane is 8 to 1. And then the pentane weighs 72.0 grams per mole. And when I do all of that math, it comes out to be 2.81 grams of pentane. Now, when you do this conversion, it's basically saying, hey, all 10 grams of oxygen reacts, how many grams of the pentane reacts? So this is how much is reacted. Well, if I wanted to figure out how much did not react, I just have to subtract the two. So if I started with 5 grams of pentane, if that's how much I started with, and 2.81 grams reacts, well, the difference between the two is how much did not react. And if I subtract the two here, it should come out to be 2.19 grams of the pentane is unreacted or left over. Okay, so when this reaction is done, okay, there's going to be 2.19 grams of pentane left over. There's no oxygen left over, okay, and we should produce 4.22 grams of water, okay, which gives us a yield of 77.1% if we only make 3.254 grams of water, okay? So some people might say, well, what about the carbon dioxide, okay? It wasn't part of the prompt, okay? You don't have to do anything with the carbon dioxide. But if you want to figure out how much carbon dioxide was produced, okay, or what should be produced, remember, always start with your limiting reactant and convert it over to the carbon dioxide. That should tell you how much carbon dioxide should be produced. Of course, if you want to figure out how much actually was produced, you could probably convert the water over the carbon dioxide, but that would be experimental, okay, not theoretical, okay? So some words that we need to be watching out for, okay, is experimental yield, theoretical yield, percent yield. They all sound similar. We also have these vocabulary words of limiting reactant and reactant excess, okay? I hope all this information made limiting reactant problems a little bit easier for you. I just want to include one extra practice problem for you to work on.